Good afternoon, everybody. Welcome back into the Dragon's Den. Everybody's doing well this evening. Welcome on in, Chewy, Timor. Hope you guys are doing well. Hope you're doing well. There's no starting music playing. That is correct. There is no music on this one for a specific reason. One, I'm going to try and get some type of music made, but as I moved the videos over to YouTube, I continued to get like not copyright, but notices that I would be demonetized, and it was never the same part of the clip. So I had to just keep removing the music out. So I just got fed up with it and said the hell with it. And it's a problem with just about anything unless you make your own or something like that. But yeah, no starting music. That is true. Your latest addition was the Anycubic Cobra S1 combo. Have not had the time to toy with it much. Seems to work. Yeah, I have mine downstairs. I was starting to print with it again. Basically, when I brought the Trident 350 up here, that freed up some space downstairs. So I put it up and plugged things in. Was starting a test print that was going to be several hours long. I didn't like the way it started off, and I went ahead and canceled it and just went to bed. But hey, Eagle, how are you? Hope you're doing well. I'm feeling okay. My sinuses just started to go a little wonky. I've got some allergy meds here. I went out and went to the office today, and we had a going away lunch for one of my coworkers. And don't mind me, I'm going to take my boots off while we're talking. So I had a going away lunch for one of my coworkers, and so it was easier to go into the office since the lunch was going to be right there. And just meant getting outside and getting into the pollen. Well, we're in pollen season, so I got to go play with the tree spooge. Um, that is pollen season. We don't call it spring here. We just refer to it as pollen. Hey, 3D Medic Vince, how's it going? Sorry for the light coming right into my eye. It's going to distract me. I think that might be why I had the thing run the other way is because yeah, the sun comes this way and it comes right down through there. So give me 1 second. Let me see if I can't rotate this the other way. Sorry about the light that's going to stream in there and blind the camera. What I really need to do is just take this board and start it at the top and just put it up with some uh, whatchamacallit strips. Cover the top portion. That way it doesn't matter if it's right here because I got a big printer in the way. Um, Hey, Mr. Wood. Yes, good afternoon. Timor, yeah, you're having print stick really good, screwing up build plate even with Vision Miner. Okay, you're saying that they're they're sticking really good, but you may have put Vision Miner on it, so it's sticking way too much. Yeah, if that's the case, go and wash it off with like Dawn Power Wash. Um, and try and clear off some of the Vision Miner. And I would say the first thing I would do on a build plate, and I often forget this because we're doing a build, um, is take the build plate, wash it off in the sink with Dawn dish soap. Make sure that whatever dish soap you're using does not have any lotions or what have you. Um, we've started using just Dawn Power Wash, but I would suggest Dawn. That gets rid of all the oils from your fingers. Make sure at that point when you're holding it, you're kind of holding it at the side so that you're not getting your fingers all over the place. Put it on there and you should be good to go. But I hadn't had any problems with the Z offset on the Anycubic from the get-go. Um, Dawn and scrubbing, yeah. Still really sticks. Um, yeah, I mean it sticks fine without the need for any vision miner. It's a brand new build plate. Most brand new build plates, especially textured build plates, should work perfectly fine. Just wash them off when you first get them before you start printing because you don't know who touched it last, whether they were with bare hands, whatnot, during the packing, whatever. It's just easier to get any, manufacturing, packing, last stuff off of it, clean it off, put it on there, and then roll. Um, First 6 months, they seem to work exactly, and then they start wearing out. And then we fight with them, and we try and get the most life out of them. So anyhow, in the last stream, we talked about a couple of the different projects that we have. We've been working on the Trident 350, and we're kind of at a stopping point. And we're at a stopping point because once we turned it over on the side, I realized, oh no, um, it it's running a Big Tree Tech Manta M5P, which meant my assumption was actually all my Vorons are running M8 or Octopus boards. I shouldn't say all of them now because one of them's got a Leviathan in it. And I was just taken aback by the fact that it had the M8P in it. And I've got an Octopus board sitting over here that we took out of Kyber Dragon, which is downstairs ready to go to Echovate. And so I was like, okay, at first thought was we'll just slap that in there. But here's the issue. We slapped that in there. Well, now we have a CB1 module that's orphaned. So we'd have to figure out a way of putting this, another Raspberry Pi or Raspberry Pi alternative into the system. If we used a straight Big Tree Tech Pi board, we should have been okay to just pull the card out and put it in the new one and would be good. But the issue is if we switch to another board altogether for the SBC, the host computer, we're going to have to reflash everything. We lose all the print history and all that good stuff, which I know it's not that big of a deal, but it sort of is. And it's just more of a pain in the butt. So what I did was I ordered a Big Tree Tech Manta M8P from West 3D because they had it in stock. And they also had the other part that I needed, which was the Beacon H probe, because we were going to put the cartographer in it that came with the Cybor all-wheel drive kit. The problem is the configuration of that board will not fit onto the part cooling fan ducts where it's supposed to mount. You say, well, just reprint the ducts. They're SLM printed. They're metal prints. And I don't really want to go and reprint the part in PC and put a polycarbonate or what have you part on the bottom after I've paid for the SLM metal part, So I just went ahead and bought the bullet and ordered a Beacon probe, and we'll put the cartographer on something else in the fleet. That's not that big of a deal. So since we're waiting on parts to come in for the Trident 350, we're waiting for parts to come in for the Kitty Tech that I'm fixing for my D&D friend. I figured we can work on the Optimus P1 electronics. And Optimus P1 electronics is this. Right? This is a regular like steel cabinet. We've got aviation grade connectors and big cables that fit down on each one of these. That one's loose. We'll have to fix that too. That'll fit down on these, and they're keyed so they'll only go on one way. So you ensure that you're getting your cables in correctly. They're labeled. So A to A, B to B, C to C, so forth. Um, but the issue I have is the only thing in this entire cabinet that is properly wired are the JST connectors and the USB cable. And by properly wired, I mean properly crimped and seated. All of these screw down terminals are bare wire. There's not a ferrule in here. It's an interesting thing where it's running an MKS Gen 1.4 board. So that's right here. And I wish I had zoom on this. At some point, I'll wind up with a third, whatchamacallit, a third uh, OBS bot camera, and I'll be able to zoom down in here some. But we've got a TMC 2208 for the X-axis in dumb mode. There's one physical motor. We've got a, and this is a, what, can I tell what manufacturer this is? Nope. It's a white one, so it could be a FISEC, it could be an MKS. I don't know, but this is a 2208 driver for X. Y is a 2209, also in dumb mode. And when I say dumb mode, I mean it's configured with the jumpers not to be in UART. Then we've got a stepper. This is something familiar to our whatchamacallit, to our BZ bot, where it's a step stick with a connector to extend out the direction, the step, and whatever. It basically runs over to these big external drivers, and this is for the Z drive. And we see these more often in CNCs, like big CNC machines. Hey, Pez Liz, welcome on in. So we've seen the standalone 5160s that we've used in a couple of our builds. These are big boys, right? And what these are running, these are going 24 volts still, but high amperage. So these are running the NEMA 23s for the Z axis that are driving 16 millimeter ball screws. So where did you get this machine? It's not mine, though I am going to claim it in my heart. So this machine resides at Ecovate 3D. I'm not, I can't remember who actually donated it, but it's been donated to Ecovate, and it had been sitting there collecting dust for a couple of years. This printer, just to recap, do I have it up here? I do not. The company is called FebTop, and they're in Sweden, I believe. Yeah, Stockholm. And so just to give you kind of a heads up here, open air, 600 by 600 by a meter, starts around 4,000 euro. The Pro, 600 by 600 by 1100, enclosed with a chamber heater, starts around 8,000 euros. Okay. And trying to find the specs, it drives me insane. There we go. Go away. get me? Yeah. So it says 100 centimeters. It's actually 1100. It says two different things through here, but this is a monster. And I'm going to scroll down. Oh, comes flat packed and chewy. If you look at this, this kind of looks like an Ender 5, right? You've got the two Z sides. They're actually come fastened together, right? And they'll come flat packed. You'll have the gantry. You'll have the two crossbars at the bottom. So you'll stand the side up. Well, you'll stand the two sides up. You'll disconnect them. You'll mount the lower front and the lower back. And then you'll add the gantry to the top. Get everything bolted, squared up, blah, 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 blah. I would probably say lay it over on its side. Put the four wheels, casters on it. Stand it back up. Now go ahead and start building your build plate. Get that installed. Hang your electronics on the side, so on and so forth. It does have a laser engraving head attachment. Thank God it did not come with it for reasons. I'm not a big proponent of lasering and printing in the same thing. It just creates way too much stuff. Done and yep. Yeah, this thing is huge. Thanks for alert, Timor. So all the linear rails, X, Y, and Z, are MGN 16 high wind rails. Okay. The other thing I didn't think of is I should probably get my little greaser, the handy dandy greaser, and finally fill this full of grease and take it with me when I go down there so we can grease up those carriages, because I am pretty sure that they are may not be bone dry, but they're probably going to need some TLC and love. 16 SFU 1610 ball screws. So these are 16 millimeter ball screws. And then here's a picture of a dude leaning up against the printer. So before I forget, Saturday's stream is going to be an evening stream. Okay? I am not going to be streaming Saturday morning because Echovate is doing their grand opening, and I think it starts at noon. And it's like a good 40-minute drive out there. So, you know, yeah. So actually it's closer to an hour, a little over an hour drive out there. So I'm not going to stream Saturday morning. I will stream Saturday evening. So I will try and get pictures of this beast between now or at the event so that we can show you this, because a lot of you have seen me at the shows. Power is out from 8 p.m. to 5 a.m. Saturday. What? Oh, and by the way, this thing has two wall outlets. And these are like 16 gauge cables, I think. I'll have to look at the wording on the side when I can get a better chance of looking at it. I think they feel like they're 16 gauge power cable. They're not thin by any means. But yes, this is the big beast. It's got two doors. So the blue stripe down is one door, and then the other part is the top door. That way, if you're not printing a really big part, you just have to open the top and pull the build plate or pull the part. It has a glass bed. So it's an aluminum plate with a mains powered silicone heat pad at the bottom with glass over the top. So MKS Gen 1.4 with custom Marlin firmware. I would love to see if I could get the actual Marlin code. I'm not sure. I'm going to reach out to them and see if they'll send me the Marlin code, because it'd be really kind of cool if we ran this on like a Kraken, maybe a Leviathan, and we'll still keep these for the Z just because we need the amperage, but get rid of this MKS Gen 1.4, go to something a little bit more modern, and get Clipper on this and see what we could do. It had a 0.6 nozzle on it. It's, we'll say clogged would be a good term. I'm not sure what they were putting through it, but yeah, I will see if I can clean up the brass volcano nozzle that was in it. However, I've got a whole new, like, I'm going to completely rebuild the tool head. As in, I've stripped the tool head down to just the metal mounting plate and everything, and I'm going to rebuild it using a nickel plated copper heat block, which is good to 500 degrees C, a 65 watt heater core. It comes with a 40 watt heater. There was a 50 in it, which is indication that they did things. She's outside, Eagle. And it came with it comes with a standard thermistor. So I've got some standard thermistors, and that will go in it initially. And I've got a all metal Batis hardened 0.6 nozzle to go in it, volcano nozzle, and I may wind up getting a 1.0 because it does come with a standard NHC 100K thermistor, which is going to limit you. Oh, it says 60 watt there. Well, it has a 50 watt in it now. Once again, tells me that somebody has fixed things. There was other indicators that I think they melted or set something on fire. But kind of where I'm going here is I'm not just going to rebuild it. I'm going to upgrade it. I've got a PT1000 here, and basically between the heater and everything else, I'll be able to get that hot end up to printing certain things. And since this is a big printer, and I have a spool, and I now know that they've got 6 spools, they being Echovate. We may be printing some things like this and other things, and this is a 3 kilo spool. So we would have the ability to print some pretty big things and do so in proper materials, whether it's the recycled PET GCF or some of the PPS or polycarbonate or other things that we have. It is 1.75. It is 1.75. But you're going to want to be running large spools on this if you're going to do anything big. And once again, it's got 2 power supplies, and one of those mains outlets, from the looks of it, is just driving the chamber heater. So we're going to get into the wire, and we're going to go through and just work our way from one side to the other, fixing things. And another thing that I've got an issue with, right? So this is our mains coming in, black, white, green, pretty natural, right? The green goes to the bus bar. There's nothing connected to it. Okay. Then when we come out, we go black and red, right? And then we've got a bunch of stuff over here on the other one, which by the way is snapped, and I'm going to have to get a replacement for that. And we're mixing blue and yellow on the 24-volt side. So I have no real idea looking at this if I'm playing with 110 or 24 volt. A bus going nowhere. That's the one I'm on. Yeah. There's a short bus somewhere. It's got my name on it. So yeah, there's some other things in here going on that I'm going to fix. So if we're going to use blue and yellow, it's it's uh, it's going to stay on the main side, and I think on the main side I will have to go down to the local store and get some more wire. And we're going to, on the mains power side, we're going to stay white, black, and green. And it's going to be thicker, it's going to be thicker gauge than the rest. The DC side, which is all 24 volt, it's going to be thinner wire, and we're going to be getting rid of some of the yellow, and we're going to go to black, red, like normal. But this should be the 120 or mains, and then the other one should be all the DC voltage. And like I said, this particular bus bar is busted in half, and so I'm going to have to order a new one of those. Or excuse me, I say bus bar, it's a terminal bar. A bus bar is like power inlet coming in, and then it's got multiple branches off of it, and they're all tied together, right? This is not that. This is a terminal block, which means each row is just a connected. And they do have these, see if I can get this up here. They do have these little like forked connectors that you can put across them, and that ties them together. So you can have all four of these should be, well, I would go, oh, that's yellow. So are we 24 volt or 110? Don't know. It's actually should be 24 volt for that, but we're gonna make sure, right? So once again, all of the connectors to the terminal blocks are bare wire. The connectors to the SSRs for the chamber heater and the bed are bare wire. I looked at one and it pulled out. That's not good. That's a neutral, which means it's live. And oh, by the way, you remember when I said, here's the power that comes in, there's ground. The other power comes in, there's ground. And here's a ground that's attached to said ground that's blue, that comes over and goes into ground on the 24 volt power supply right next to the other blue that's bringing in, or no. Well, right next to the other blue that's voltage coming out, that's 24 volts coming out, right? There is not a single ground to this chassis. This chassis is connected by 4 bolts to the side of the printer, which means the entire printer is ungrounded. There's no hot glue, no. So yeah, that's where I said I want to render this safe. There is nothing safe about this right now, which is killing me. Like the power supply is not secured. One of the SSRs is not secure. The other SSR has a single bolt through it that's not the correct size, and has a nut on it. Everything in here is drilled and tapped for M4. That tells me that if you're having to put a nut on it, that's not an M4 bolt. The front of this, right? I like chamber, printed in PLA. This is the information for the chamber heater. There's your main power on and off, and you've got the emergency stop switch. So you turn the power on, and then you do to actually engage the 120, right? And so you've got the proper safety mechanisms here. And the wiring is crap, which I'll say kind of tells me, okay, let me step back for a second. There are mods like this. There's a printed part here that had a fan to cool this. This is not a quality part, right? There's other parts that we've seen on the print head that were PLA. There's a mount for a BL Touch on the print head. It was PLA, maybe PETG, and it was already warping. Right, so I'm not sure if this is the way it came from the factory or if somebody was tinkering and did some of this. I don't think somebody would have redone all those terminal blocks though. I don't know. For $8,000+ printer, I would assume that they would at least put fork connectors on it. But we're putting fork connectors on things. I got some extra M4 hardware to make sure that things are connected properly so that this is going to be connected physically to the chassis through the screw hole standoff. Chassis is going to have a ground to it and everything's going to be properly grounded. So polymorph, this printer, once again, we'll come back up here to the full display. This printer, which is this bad boy right here with a average size adult sitting next to it. This is the standard machine, open air. This is the Pro, which is enclosed. This is a Pro machine, right, at Ecovate. Correct, Mr. Rizix. Ecovate. For the life of me, I keep saying Evocate. It's Ecovate. Ecological Innovate. But it's Ecovate 3D. It's a local shop in town, and this was donated to the shop. The person that had it, it was taking up space in their house. They hadn't used it in a couple of years. I think the last time it was really used, they had taken it to a show, one of the Rep Rap festivals, and it basically was sitting there. No, this belongs to the store. I am helping getting it going, and they asked me if I could come take a look at the wiring because, well, they've talked to me and they've seen my builds. And in fact, they want me to come and teach some classes and stuff as well. But I went down there Monday, which they're not open, right? One of the other employees there that works close by came down, let me in, and we started looking through this and tracing the wires and stuff. And like, I was just cringing. Like I was to the point where I was like, okay, I'm going to come back Wednesday and bring all my tools. And he looked at me and goes, there's 2 bolts holding this in. Why don't you just take it home? I was like, done. Right. So I brought this home, and like I said, the tool head, I have completely taken the tool head apart. In fact, I just washed this, but you can still see some of what was left. There was a burn pattern here all the way around, which kind of tells me in some heavy soot, right? Which was kind of telling me like it was looking like this. So that tells me that somebody has let some magic smoke out. This blower fan, which is the part cooling fan, I was digging filament out of the inside of this. This fan's it's a Bluetooth fan, right? It's Bluetooth. So this is the out, this is the in. This is how everything was mounted. So that goes like that goes like that, and this went like that. So you tell me, where is this fan getting air from? This little tiny gap up here is the only place that it could pull air from. So it's no wonder that this fan doesn't move very well. It's all kinds of crunchy. It's partially melted on the inside. So new fans. There's your hot end. Professional machine, right? This is the heat break. PTFE line heat break, right? Down to the block with a volcano nozzle. And that's where I'm saying, yeah, they cooked something. I don't know what, but they cooked whatever they were trying to print. And yeah. The extruder, which I realized and found out this is the same exact extruder as the Keytech. So you kind of see that hole is not round. You turn it the other way and see if I can get the angle right. Pretty sure that should not be see-through. It was only a matter of time before this completely broke out. So there's new ones of these online or on order. In fact, I've got 2 of the plastic ones on order from Sweden. I got shipment notification today coming from Sweden. Here's our BL Touch mount. And looking at it, yeah, that should be PETG. But it's warped. It's warped. So we're going to reprint that and probably some polycarbonate. Since I was ordering stuff from Sweden, I went ahead and ordered a couple of new gears because this looks a little mangled, like mangled to the point that it looks like somebody put pliers on it. So I've got a couple of gears on order. That comes on and off. There is a set screw on that particular gear. And something else. Now, the extruder pieces I have coming from them are plastic. I may have stumbled across a Bunser version of it that's metal. That's on its way from AliExpress. But we'll be putting this together later on a different stream because I think we've got plenty enough to do here. And there's a part of me that just I think what I'm going to do is just work on swapping a good portion of this out with fork connectors now. And when I'm going to have to go get some new cable, some white cable to do my white jumpers. But anything that I can swap or anything that I can get correct cables on now, I will. And then anything that's going to need to be replaced, I'll leave it as bare wire for now. It makes no sense to waste a crimp connector to crimp on it and then replace it as soon as I go down to the the local Lowe's and get me some white wire, or hell, for that matter, I've got wire. I'll just cut another. I mean, this is a cord. I'll just cut another power cord, cut the ends off, and strip the wire out of it, and that'll give me the white wire. I don't even need to go to the store. Um, I buy power cords like 10 or 12 at a time on Amazon just to have. And normally when I go to shows, people are like, "Oh crap, does anybody have a power cord?" Yep, here you go. And then half the time I don't get them back, but that's fine. The other thing, this plate is missing. So that means hands can get into 110, right? Really not good. But have a laser. Or we can CAD one of these up real fast and just print it on the printer once we get it up and running. Yeah. So with no with it yeah, without further ado, I think what I'm going to do is actually I'm going to undo some wire ties here so I can pull some things out. I really want to get that whole fan out of there for now. And I have a feeling this is wired directly into one of these terminals. Actually, is this? Yeah, this is screwed in from the backside. Give me a second. I'm going to undo the mount for that fan just to get that out of the way as well. God, we'll get this out of the way. That way we can get into the electronics a little bit easier. And probably what I think I'll do is rather than put it right there, potentially just mount it when we CAD up a side panel for this. We'll just mount the fan on the side panel to pull in fresh air. And that way we'll have it mounted to the side panel, or we'll have it mounted up here. So we'll have a fan here. We either put an exhaust fan in the back or just a vent. That way we can have airflow through here. But this will let me get into these wires. And once again, this is the main power coming in. We're using blue yellow. I mean, technically, I think blue yellow is good. So there's those two wires. Is blue yellow standard DC for Europe, or is it AC? I say Europe, maybe international. I don't know. I'm used to seeing, and this is an always on fan. Probably just the easiest way to connect it. What I may want to do as well is D. I have no real wire map for this, by the way. I saw somebody ask about a wire diagram. I don't have one. So I may work on that right now while we're redoing some wiring and go through and be like, hey, this is D. Looks like D7 and D6 are going to blah blah, right? So we'll possibly work on that as we take these off and put ferrules on all of these wires because that's just disturbing. It bothers me. Sixth and 7, which is hot end, negative, and positive. E6 is hot end negative. Um, Start taking notes. E6, 0, negative. 7 is HE0, positive. Color codes USA, UK. There we go. Thank you. USA wire color codes by AC, by DC. I would. This is a U or not UK. This is an EU machine. Like I said, it comes from uh, Stockholm, so that would be Sweden. Table of content. Europe. Black, gray, neutral blue, ground green with yellow stripe. So neutral is blue. So that's as long as neutral would be mains though, right? So blue being on neutral isn't bad. It's when you start using a blue for a ground cable that gets bad. Um, two-wire underground or two-wire ungrounded DC is brown and gray. Two-wire grounded circuit, negative is brown, voltage negative, blue, positive grounded circuit is blue. So it's either brown and blue or blue and gray, and blue can be negative or positive. That just scared the crap out of me. That's okay, but nothing in here that I'm seeing says yellow. So that's good. It will match. It'll be common some way, shape, or form by the end of this. DC is going to be, I'll say black and red as much as I can because some of these wires, like all of these wires going, up through the connectors are all black. I get that. We just need to make sure that we keep things situated. And what size? 20 gauge? I don't think 18 gauge. That would be 20. We route it down and under the board. These are aviation grade connectors and cables, so that's good. It's just a matter of properly terminating them because I really don't like bare wire. And because I'm looking at these terminals, I am going to go ahead on the smaller terminals and just go ahead and snip off the last segment of the crimp. So that goes over there and out of the way. And I'm going to do these one at a time and try and reroute them back the way they were so that we're not messing things up too bad. There's somebody went through and put down a ton of wire ties. So that's nice, but some of the routing is not the best. We may switch some of the routing around. But doing this one at a time will ensure that we get everything back the way it was. It'll be a little bit slower, but we make sure that we're getting everything back the way it was, especially when we're doing things like this where we can't really, oh, what wire are you? That one. Where we don't have a really good map. Like, there's some places where I love to, clean up the wiring. And as long as these move, which it looks like the labels aren't fully shrunk down, they can move. Some of these may be cleaned up, rerouted, and shortened to reduce the, massive service loops that are in here. Make the wiring overall neater. I also want to be careful that I don't nerf myself. And by nerfing myself, I mean, hey, let me cut this shorter. And then we decide to swap a board out later on, and we can't because we've cut the wire short and it no longer fits anything. I mean, yes, we can solder it together, but why go through and resolder or solder things together if we don't have to? Certain color zip ties mean forward at, yeah. Yep. Okay, so one done. This is going to be the next one. This is still going to go back into D. We'll find out here in a second. Push this wire out. D3. And this is going to something I can't. Oh, fan. HE1, HE0 fan. So this is either part or either part or hot end. Figure that out. D3. fan, and that was fan negative. Great, Timor, sounds great. Yeah, we're going to be doing a lot of this right here. We're documenting stuff, and I'll get everything written down as I go through and do it, and then um we'll work on putting it into like a spreadsheet or something. So I'll create a big spreadsheet, print that out, and that way we can put a spreadsheet in here for whoever works on this next to have something a little bit better to use for a wiring guide. And for those of you wondering why I'm crimping on a terminal and then cutting it a little bit shorter, one, I'm not cutting much off, very little, but if you don't do that, then you'll have oh, interesting. Okay, I've got wires moving around here. So that's the negative. The positive, I just pulled the positive out. This is the positive triggering the bed heater. Probably not something we want to just be popping out, huh? I mean, it's granted, it's just a signal, so it should be low voltage, but said low voltage is going to the um, bed heater MOSFET. Still not a good thing. But the reason I cut the tips off of these is to ensure that the ferrule, when it goes in, it goes all the way in to the plastic bit, and all I'm taking off is this very small piece right there. So it's not like I'm taking off a bunch, but it's enough that it can stick all the way in and make good positive contact. Um, the last thing you want is to have metal still sticking out after putting a ferrule on it. And that's another place where it can arc because these ferrules are right close together, and electricity takes the path of least resistance. And if it can arc, it will arc. Where's the heat shrink label maker at? It's sitting over in the corner with a pile of stuff over the top of it. Um, what I would, what I could possibly do is just label the SSRs themselves. And you see, I'm getting my crimp on there, and I'm putting my finger over the top. That way, when I snip that end off, it doesn't go flying into the cabinet, and I can pull it out and make sure that it's not a metal shard just flying around in the cabinet here. Okay, now decision time. They've got blue and yellow. Which I'm not necessarily that heartbroken over. I say that, but let me double check. Okay, yeah, blue is at least in the negative side of the terminal. Yeah. So, which would make sense because yellow sun, hot, blue, ocean, cold. I can live with that. Like I said, my biggest thing is mains needs to, like, these are the cords coming in. I want all my mains to follow this. Everything else I can live with a mixture of blue negative, yellow hot, and red and black. I think we can both, or we can all live with that, especially if I make note of it, um, and have proper notes in it. In fact, I might actually like make a label and put a label on the outside or in here that says um, yellow, red, hot, DC hot, blue or black, DC negative, and then, you know, black, white, and green would be our 120. And you should be able to tell the difference between a trigger pin and a high, the higher voltage pin, because the higher voltage is going to be a thicker wire. I will make sure that that's done everywhere. Greek food time. Go Pezliz. I had huh, that's not gonna work. I had the mez, which is kind of like South American, well, not Central American food. I'm not sure if they're Mexican per se, but I did have some enchilada stuff. But they've got various things, and it was good. It was the going away lunch for my guy that's leaving. Okay, and I'm putting this in the right place. So positive at the top, negative towards me. Okay, and they're like bringing it all up here. So see, this is the issue. So this is our switched hot, and it comes up to the main switch and it comes up into here. And this is using yellow, and these yellows, these yellows, which have now come off, which is good, come down and switching to 24 or what? Where is this one? Okay, so that's fine. This is 24 volt and this is 24 volt. So this is killing power to the board across 24 volt. I can live with that. I can live with that. Chamber. I'm going to wind up redoing some of the wiring mess because I think routing might be a little bit different here in the near future. Because I think all of this power routing, I want to run right up along the top edge here out of the way. It either goes at the top or it goes at the bottom. I want 24 volt all at the top, and I only want our our mains down at the bottom. as much as I can. So we will have to work that around. Okay. That's good. Comes down here. Oh. Be careful when you're snipping these zip ties that you don't get the wires. Really don't want to be snipping your wire. That one's going there. One goes to the one that's busted in. Mine goes. Like where they choose to route some of these wires is just what's not making perfect sense. Like why? And this is why I'm not sure if this is, I'll say, a factory wire job or an after the fact wire job. Some of the wires still have the tails, or the wire ties still have the tails on them. Um, that. So what I want is as Chewy was talking about, this should be 24 volt to the we'll say PSU. This is 24 volt PSU. This is 24 volt from switch. So as Chewy noted, do have the label maker. Let me just try and dig it out real fast so that we can do the right thing, since that's what we're trying to do. Do the right thing. Thanks for calling me out there, Chewy. Label maker, power supply, because I always need to use that every time I go to turn this on. Never seems to hold a charge. Probably look and see if I even got batteries to hold a charge. Could be part of my problem. And so we got 24 volt to switch. turn on, we're going to be doing um, oh, heat shrink tubing. What? Label link. Auto. Okay, and we're 24 volt to panel switch. I'm going to make these long, but that's okay. Make them real long. Isn't necessarily okay, but we'll live with it. .24 volt to switch. So 24 volt panel to switch. Be able to heat shrink that down, or we could just leave it like it is and um it'll be fine. Yikes. Yikes was me looking as my uh, divider and my thing came out. Okay, so this gets a fork terminal actually, which will be a different crimp tool, but we've got those. Hey, Bearded Printer, welcome on in. Sorry I didn't notice you when you first popped in. We are trying to fix up some wiring. We've got a hodgepodge here, and what we've decided, what I've kind of decided is I'm going to live with the mix of blue and yellow and red and black for DC, but everywhere where we've got our um everywhere where we have our um mains voltage, we will be swapping that over and doing um proper wire colors, or at least matching wire colors, because I've got some places where they're running blue right next to another blue. One of those blues is ground and one's neutral, which is bad. There's also not a chassis ground in this whole thing, so we'll be solving that problem as well. None of the wires going into a screw down terminal, whether that screw down terminal is on a MCU or to a bus bar, were properly ferruled or what have you. Which once again we'll go with the word bad. And where was the how much is the dog in the window? Um, I really wish. I'm gonna see if I can't. I want to try and can I get these out? Top, bottom, one at the top. But okay. Um, I'm gonna try and just make it easier for me to get in here and see something. Ground goes to nothing because why would we want to ground anything? Screwdriver. What I'm going to try and do is just clear some things out to make it easier for me to work in here. There's one. Oh, that alone might just make it easy enough because I've got these two wires that just need to get routed underneath. Like, why am I looking at this all along? Hey, look, that's easy. So we've got 24 volt and common ground. And this is the other part that I'm looking at is red and black. This is line and neutral coming in from mains power. Blue for a ground that comes over and connects for a ground. So you've got a big gauge wire and then you go with the smallest wire you can for a ground. Right next to another blue that's common, a red that is uncommon, and two yellows for positive. This is dangerous and scares the bejesus out of me. That's why I want to get this cleaned up. This either needs to be all, well, once again, I would be fine with yellow and red for positive and blue and black for ground. Mixing red, blue between ground and ground, I just that just scares the hell out of me. It scares the hell out of me. Um, but I need this a little bit out of the way. This is coming over to switched. I'm going to undo the positive and negative from here. Easy to tell because they're thicker wires. Blue to ground, because that one's definitely going to get replaced. Okay, and then these need to be swapped out, placed, rerouted, properly routed, something. Yes, I'm apparently going away from the one wire at a time edict that I made earlier. Because once again, all my yellows were going to high. I can't do that one just yet because there is a, sure I can. The one thing I could do, no, I don't want to do that. We'll stick with the plan. Stick with the plan. Um, Stick with the plan. Um, so if all of this is switching 24 volt, is it all switching? No, it's not. So so this one's busted and I've ordered a new one. What I can try and do is one for positive, one for negative for the DC side, and I can get full length bus bars that turns it into one connection up from here to negative, one connection from here up to positive, and then all the positives to one, all the negatives to the other. Makes life super, super simple. Hey, Harold, how's it going? Welcome on in. Welcome on in. But what that will require me to do is to trace all these other wires and figure out which ones are my grounds, get those separated out, and make sure that we're going, I'll say, the right way. Okay, so this is 24 volt panel to switch. This one is 24 volt emergency switch for the PSU, not PSU technically. Emergency switch to 24 volt. Um, so um a lot of the stuff here just wasn't labeled, right? We've got things that are coming from our aviation connectors at the top of the machine to the um, board. So that's easy enough. We're going to basically create a pinout diagram. What we're doing now is, in essence, what is power distribution. And that's why we've got the bus bars. And what I really want to do is create a positive bus, a negative bus, and a just a, we'll say, a mixed or mains voltage. I think that will make the wiring a lot safer. I definitely want to clean up because we've got blue wire and red wire being mixed in here, um, which, like I said, I'm not necessarily too worried about that as long as it's all being used for DC or AC. And what we're finding is we've got a bunch that is DC, and we had like a blue ground wire. Like, why? Um, and that blue ground wire was ground AC next to a blue wire that's being used for um, DC common, DC negative. So that's bad juju. That's going to lead to somebody inadvertently swapping a wire at some point, and next thing you know, you've got 120 going someplace where it shouldn't be. That's going to come up here. We've got those two labeled. This is this is 24 volt to MCU. All of these were bare wire in screw down terminals, so I'm taking the time to put whatchamacallit, fork terminals or ferrules on them as appropriate. So MCU to 20, because that's the MCU to 24 volt. Print. Row. And cartridge is out. Good thing I've got a bunch of those. Tape. This is heat shrink tube. Yes, they are important. Like I said, in the best of both worlds, I may have enough extra length here that I can I might have enough extra length here that I can cut some of the yellow wire down and the blue wire down and use it as appropriate. Not sure. We'll see. Stop throwing away things that you can be handwritten on. Okay, we're going to print. Data feed. Really? Try that again. Print. Okay to feed. Okay, something's not working right. What did I do? Uh-oh. We got something caught in there. Try that again this time. See if we get Okay. Sorry about that. Wasn't paying full attention to chat there. Yeah, wire standards are definitely electrifying and important. Um, Having good wire labeling is always important, especially in a system like this where, potentially, right? We've got NEMA 23 motors for the Z. Like I could also see some point, I know I kind of alluded to it. We're going to get this thing running, and we're going to get this thing running as soon as I get the brass wire or the copper wire out of my finger. There we go. We're going to get it operating initially in its current form using its current firmware. And we'll pull whatever information we can from standard Marlin, right? And if we can't pull it and we need it, then and when I say standard Marlin, I mean pulling it from the Marlin screens. And if we need to, I will reach back to the company and um not sure where that one went. This one, these are together and they probably don't need to be. Um, I'll reach out to the company and see about getting a Marlin config from them. And that will give us the ability to open it up in Marlin, pull back the cover, so to speak, and be able to set up Clipper. Because I think this machine, a 600 by 600 by 1100 machine, would would do wonders on Clipper. Okay, so this is 24 volt EXT ERV1. Right. Yeah, because if we can get it and take this to Clipper, maybe throw like, I don't know, a Kraken board at it. This is an 800 watt, 24 volt Meanwell power supply. I believe it was a Meanwell. Yeah, Meanwell power supply, which is a chunky beast. The reason it's 800 watt is because we're running these external drivers and to the NEMA 23s, and I believe these external drivers are set for, well, let me grab this one and we'll look at it. 4 and 8. 4 is current. So everything off except for switch 4. 4.8 amps. 4.8 amps at 24 volts. So 5 amps, 5 amps, there's 10 amps, plus the board, plus the hot end and everything else. I could see throwing in a 48 volt, right? Throwing in like a 48 volt, because this will do, I think it can do 48 volt. I think these will go, yeah, 20 to 90 volt DC input. So I could see swapping this out to maybe like a 350 24 volt and a 350 48 volt, running the 48 volt dedicated down to the Z motors, 24 volt everywhere else. We should have plenty of voltage at that. And then, yeah, that could work, I think. But once again, I'm, at that point, I got to just talk to Beverly and be like, hey, Beverly, how about I own this? It sits here, pulls power. All right, so that one's there. This one is the other one. So this is to external driver 2, backspace 2, print. Okay to feed, yes. And once again, these are heat shrink tubes so that I can shrink them or not. It doesn't really matter. It works out well for doing labeling either way. Um, um, I don't know if I want to go 48 volt all motors, just because um, the main made that one too. Well, cut the wires too. The the X and Y, I don't know. I really running 48 volts to the big stepper motors is just more about giving them plenty of power and torque to deal with a larger print. You would think that it would have plenty if that's what it was spec'd out for, was 24 volt. I just think it'd be more efficient running it at 48 versus 24 on NEMA 23 motors. The other ones, I'll have to double look and see if they're oversized motors. Then okay, maybe take the rest up to 48 volt as well. I know the extruder is a standard NEMA 17 though. Okay, so that's the power there. The other thing that I want to look at here while I've got it, 1, 2, 4, 3. Awesome. This is going up to B. Okay. So we're trying to document this as we go. These 4 are coming up to D. There's a bunch of other stuff coming up to D that I'll document here a little bit later. This one we said was going up to C, which looks to be feeding both of the motors. So C1, 2, 3, and 4. So when I say 0, 1, this is cable 1 on C, which is the aviation connector C. And what I need to do is figure out the hell they're going to. So B minus, B plus, 3 is A plus, 4 is A minus. And these are driver 2. Driver 1 up here, gotta pop this out and make it easier to look at and read, is 5, 6, 7, 8. And once again, 5 is B minus, 8 is B plus, or no, rephrase that, 0, 6 is B, 8 is A minus, makes 7 A plus. Okay. So there we go. There's our cables. We'll have positive wires coming over to positive. We'll have negative wires. I'll go over to the negative side. Like I said, I think what I'm going to do is just run, there's screw down terminals over here where I can run 3 different sets of screw downs. So I'll run 3 bus bars. One will be DC positive, one will be DC negative. The other is going to be mixed shared 120 or mains. And we'll just kind of lay that out as like positive, negative, ground, using appropriate colored wires to make life safer and easier. Okay, we are on driver 2. We want E and D. Okay, so I've got driver 1 and driver 2 labels here for ground. Two, 1. Driver 1's ground. Hey, zombie, how's it going? We're playing with wiring, and it's worse than I thought. We actually had, well, one, we're mixing color schemes, right? So we've got a mixture of blue and yellow, and that mixture is so far, for the most part, been yellow for positive and blue for ground on the DC side. Until we also had a blue ground wire to the 110 power supply. So that was kind of a little bit wonky there. So yeah, we're trying to clean up the wiring to make it safe so that we don't inadvertently connect something to the wrong thing or potentially, shock or kill somebody. That would be bad. The bus bar for the what appears to be the all DC side of things, that is broken in half. I say bus bar, it's terminal bar. I'm going to be ordering 2 new ones. And because I'm getting 2 new ones, the plan will then be to make one dedicated because I have the mounts that I can mount 3 of these bus bars. I'll dedicate one to 24 volt positive, one to DC ground, and then the other one we'll leave it as a terminal block without making it a true bus bar, so to speak. And that will be kind of all the main stuff coming in. So we'll bring both the mains in, and the way I had it working was one mains power was dedicated to the chamber, the other mains power came in for the bed and the power supply for the 24 volt. So we'll do that. We'll leave it a dedicated power for the chamber heater, and then the rest will be a standard printer type thing. There's our cables that'll plug into our 2 driver boards up here. Now the other thing that we've got, and let me disconnect this. Whoops. One of the other things we have is there's like no chassis ground here. So none of the stuff is actually grounded. So that's good. Here, grounds are overrated. So this is the what we've got. We've got the positive pulse, negative pulse, direction plus, and where are we jumping? We're jumping pulse negative to direction negative to enable negative. So we're taking to ground, enable, direction, and pulse. So we're just combining all the negatives together. And then we're bringing pulse positive, pulse, or we're bringing the pulse positive, the direction positive, and the enable positive. We're jumpering the 2 together with bare wire. That made my head hurt. Now the question is, on these screw down terminals, is it worth putting ferrules on these? I think so. I see a lot of people running CNCs that are just running these bare wire. Um, I don't know. What do you guys think? Should we put ferrules on these? These are just signal wires. I can be talked into either way. I mean, I'm definitely putting fork connectors and ferrules on all the power stuff, but signal, eh, yeah. S not helping. Meh. Signal not so much. Okay. Now the other thing I do need to do is actually get the other signal cables in here and screwed down. So that one goes there. The blue's going to go there. I have a feeling that that wire is, or that the wire was just pulled out and that one's too big. Pull the iFixit out. Not that one. Which one am I looking for? This one. Blue one comes from there, goes into there. And that just, all right, maybe I might want to do a ferrule for the single wires because trying to clamp that down, it just pulled straight back out. Oh, we're in there. Okay, we're good. We're good. So part of what I want to do, like I said, is just get some of the cable routing a little bit cleaner. The They just have it running all over the place. That's good. Um, like this would be back here. That stuff can go up along the top edge. That's fine. These are a little bit longer than they truly need to be, but I'll live with it. The What do we got here? We've got two wires to come down, go around, go up, and these are coming into awesome. So that's a 24-volt power because I've got jumper here, and this was power. So this is 24-volt. Going to a blue again. Nope. So 24-volt there. These are all negatives. Okay, so these three were tied to negatives. So these are negative somethings. Negative, negative. Good question. Crap. We got this is a negative. Coming up, going into that connector, which is A, B, C, D. D1 and D2. D2 we know is Undocumented because I just threw my pen around. Ugh. D2 is going to a... Wait a minute. So this is, there was 24 volt here, 24 volt coming around here, bus barred out. So this is connecting these three legs together. So this one and this one should be positive. And once again, this is now, that makes no sense because this is negative, which ties into these, making that negative, which would make that one technically a negative wire. What in the ever-loving hell? Because this is where the positive was coming in. So we've got positive coming in here, positive to positive jumper, which should make this positive, and then this is the flipping negative that goes to the MCU. See, that's what scares the hell out of me. So should this all be negative or should this all be positive? I'm thinking it should be positive. So D2, or I'm sorry, pin 2 of that cable and 1 and 2 of D. D, where was D going? D was going to the hot end, the thermistor, part cooling fan, hot end fan, and the BL Touch. This is definitely the blue that's going to the board because I only have one blue over on this side. So this is a negative. And once again, that's jumpered to what looks like positive with a yellow cable. Hey, what's going on, Free Heathen? Oh, no. I am documenting like what pin of which connector is going where. And I now have a yellow, which we have determined all of the yellows have been 24 volt DC. And you see that this yellow on the terminal block goes to this connector, which is jumpered with this bus bar connector. So I'm at first thinking, okay, all of these should be positive. Well, this is the negative coming from the controller board. And the positive coming from the controller board was plugged in here. So we basically looped positive and negative together. Milling and then printing with dual extrusion. Yep. Hey, Wolfman, how's it going? Thank you for the raid, Free Heathen. Welcome on in. You think blue is your favorite color of wire? Yeah, that makes sense. Yeah, so I've been trying to replace these with forked terminals because that's going to be better than bare wire connections on these. And once again, these two black wires that I'm holding right, so the blue wire is going to the MCU. The two black wires back here are going to the aviation jack connector on D, and D being the connectors to basically the hot end. So the heater, the thermistor, the PC or the part cooling fan, the hot end fan, and the BL Touch. My head hurts. So here's a thought. There is positive and negative for the hot end. There is the fan. That might be it. What do we got here? Board wise. Okay, good to know. So the hot end is coming back to the board. So the MCU is providing negative and positive for the hot end itself. The fan is only connected to negative, which makes sense because it's switched on negative, which means it has to be getting power from one of the other connections. So that's now telling me that the connection that is probably connected wrong is the negative to the board, and this is 24 volt jumping over to 3 pins here. Because if we've got two connections here that are connected by this power that's going up into that connector. God damn it. Cutting more of these zip ties. This is me having to do wire tracing, and I don't necessarily have the business end to do end-to-end pin-out verification, but trust me, I will before we apply power to this. Okay, so this one and this one are going up to connector D. And knowing what we've got on connector D, we've got hot end. Both the hot end connectors are accounted for. So we'll kind of just put a little tick there. Thermistor, I'm going to assume my thermistor wires go all the way up. Yeah, I'm just going to make the assumption that my thermistor wires are going all the way up. We'll check which ones are there. Because they're not going to be powered anyhow. So that means that these have to be PC and hot end fan power. I just don't know which is which. Do I have... So hold that thought. I might actually know which is which because I have the business end of that here. So we may put this together tonight as well. So there's cable D, right? Got cable D listed there. Damn you. Here's the heater, thermistor. So it's obviously not those two. BL Touch are going to be routed all the way back. There's the fans. And positives are joined together in here, and the negatives are separate. Well, crap. No, not necessarily. That's not going to be crap. because once again, the negative is switched. So the fan, the controlled fan negative, that one's there. What else do we have coming from D that comes from that? We've got resets cables. So we've got the BL Touch, in-stop, thermistor. One, two, in-stop, BL Touch stuff. This is where it might be helpful to have the Marlin code, because I've got, it's got the, he has, BL Touch, the hot end, the PC fan, thermistor, and the thermistor is going to come back directly. That'll be there. Are we certain that all of this bundle is going to D? It appears so. An awful lot of wires be going all back to D. But I see no other bundle of wires joining in here. All of this should be going to D. Okay. Probably because D probably has the most number of wires. I just saw 14s. Okay. Crap. Still doesn't tell me whether it's positive or negative. Negatives were separate. Positives were combined. Well, hold on. Yeah, we got 3 wires coming in. 2 of them are negative, and the 2 positive wires for the fans were joined into a single pin. 3-wire connector. And none of the wires on the business end here are actually pinned out, so I don't know which is which. I might be able to find, I'll have to pin that out to figure it out. I can pin it out. It's just gonna, I'll do that off stream. Question is 2 and 1 on cable D, right? 2 and 1 on cable D, they're either positive or negative. Almost screams that that's positive. Because we've got a negative switched up here. But where the hell would the other negative be? That's what's throwing me off, I guess. If it's negative switched, okay, we've got one switched at the or one of the switches goes to the board, which we'd expect, right? But where the hell is the other negative going to and being called and triggered from? That's what I don't know. Because end stops, thermistors, so 4 and 5 would be a thermistor. EH. Which thermistor? Coming from D would make sense. You're kidding me. Somehow on D, did they do both thermistors? So 4 and 5, and then 13 and 14 are the other ones. "13 and 14 are also thermistor. One's going to be the hot end and one's going to be the bed. Say which on the board. Why? No, it does not. It does not. So that's, I'm going to have to pull up the um, I'm going to have to pull up the board schematic to verify. But we've got two different thermistors. The other thermistor is dedicated wiring that comes out here. I believe? No, where is these going? Coming out that jack. Oh, no, yeah, that makes, I think that makes sense. I think. I don't know. I do not know. Well, that's useless. All right, so it looks like I'm going to have like 90% of the wiring done, and I'm going to have to be pinning some things out because there's a DC common that's well to a broken part of the bus bar. So the power supply is now out. That's good. Okay. Positive is something. This is negative and positive. These were going to the power supply, I believe. Appears to be positive. Once again, joined here to be 6. Awesome. These are 6 and 7 going to connector echo. One should be positive, and we're going to assume one's negative. Echo. What's on echo? extruder, and what I feel is probably the laser or blank connector. Two and seven on, well, two's over here, 1 and 2 of D. Seven of C, 6. E is blank stepper and what I feel is the laser side of things. So I'm beginning to think that this side was negative and they just happen to use this wire for negative even though it's positive. Blue wire would have been coming in here for positive. Or I'm sorry, for negative. So this is the erroneous wire that's throwing me for a loop. Because this is once again blue, so it's kind of like this side over here would have been DC negative, this would have been DC positive. I think that's how they're splitting this up. So that would put 1 and 2 of cable D as, but once again, if that's negative, I swear this is going to give me a cornea or a stroke or something. If that's the negative, then we would expect this to be positive, and it's not. This is negative. Which would mean it would have to be pulling positive from over here, switch negative for the hot end, but where's the other negative for the part cooling fan? I'm so confused now. Because once again, everything on D is going to the tool head. We've accounted for extruder 0. We've got part of the PC fan, or not PC fan, but the hot end fan. Or would it be? Let me see something. This is an NKS Gen 1.4. There's nothing in here. I don't have a manual or anything for this, and I don't think I'm going to get a manual from them. MKS Gen 1.4. You know. Um, what I'm going to do is just pull, see if I can get one of these to. Yeah, that's not really going to help. It's going to tell you what's 5 volt, what's ground and stuff. It's not going to tell me, like, I know that these are the thermistors, but which thermistor? That it doesn't tell me. 0 and 1, fan, heated bed, power. Neither one of those are done. This is the 11 5-volt and ground. Middle two sets are empty. D4 ground. This is my BL Touch wiring. Then from different connector. This, I think, is the servo. And then the end stop is what it's using for, so it's doing servo on one side and end stop on the other for the BL Touch. Add that stuff for me. And so 8. Ground 9, 5-volt, 10. This is the BL Touch servo side. Then we've got 11 and 12, with 11 being bottom side. So 11 is signal, which would be some of these do have designator clips on. E18 and 12 is ground. E minus delta. Okay, got that done. We still don't know. We know that 2 of them are thermistors. We don't know the difference between which is which. And there's nothing on here that says which is normally used for which. So we'll have to pin that out to try and see. And then once again, we've got 1 and 2, which could be either positive or negative. We're thinking more along this lines that it might be negative or ground. But once again, that would not make sense, because now we've accounted for the BL Touch, the hot end, and 2 sets of thermometers, which means it would be to the hot end, or to the fans. We've got a negative switched over here already, unless this should be positive. The only other thing I can think of is the negatives are different, the positive is not. So maybe this is on the wrong pin. I don't know. Because positive would be constant, negative would be switched, right? So it has to be on the negative, which would mean these would be positive, and I'm just still getting thrown off then. That would make D7, or excuse me, number pin 7 on A, B, on E. That would make 7 on E a negative. What do we have on E? extruder, laser, and a blank stepper. And by extruder, it's an extruder motor, and then a laser and a blank stepper. So if we think 7, if we think these are positives, then 7 will be positive and 6 would be a negative. But once again, that's going to a yellow wire, which we've already determined is most likely positives. I'm confused. I'm so confused. So if this one's to a negative, this one's to a negative, this goes to a positive. So that would make a part cooling fan always on. It makes more sense that this would be positives. But where the hell would be the switch for the other fan? Turn the other fan on. I'm going to have to pin that out. That's just how that's going to have to happen. We're going to have to pin it out. My brain's hurting. I'll just pin that out a little bit later off stream. So I think we've accounted for all of D. C, we've got the 2 drivers. C is this back one. This is the only bundle going to and coming from C. So our Z drivers are the only thing that's on C. So, E. Start figuring out E. E is this bundle, where we've got a couple of ones that we're not going to be able to figure out, and a bunch of others. Go with 15. This reminds me of work. Looks at the, yeah, yeah. I get that, free heathen. So these are simply not used. They're 8, 13, and 14. But they're not cut off at this end, which is good, I guess. I say that because most of the wires on the other end have been cut, so that's great. What are we dealing with now? We're dealing with, this is the E bundle, right? Yes, which is extruder and a laser. Gotcha. Okay. So the easiest way is going to be pull this connector, and this is the E1 connector that doesn't have anything connected to it on the other end. And 1, 10, 11, 12, and 9, because why not? The 9 is 1B, 12, 1A, 11, 2A, 10, 2B. And that's the only thing we can think of is this is for the E1 laser, maybe. So there's not a driver in the board. There's no driver in the actual MCU, and at the other end, it's just, I mean, it's a JST connector that's nothing's connected to. The only thing I can think of is there should be a driver here if you ordered it with the laser module, and it's literally 4 screws. You undo the 2 D and E connectors, and then you put on your laser and connect in those cables. What do we got here? So number 1B, or 2, 1A, 3, third one. Number 4 is 2A. Make number 3 2B. Love when they get kicked. Okay, so there's those 2. We've got one that comes out, and cable 5 is E4. So this is E0 rear. So we've got a signal ping going into D4. What else is running on extruder? We have laser, blank stepper. So it's got to be a signal pin for laser, probably. The routing is just, I mean, not trying. Here's the 3 not used. We'll wrap those around, rejoin them right there. Grab some zip ties. Oh, I got some right here. That down there, get that done a little bit nicer. Still have two cables that come over this way that I'm just still not sure which should be which. 6 or 7. 24 volts. That's got to be the 6 or 7 on this. It's 24 volt. It's going to be coming over to this got to be for the laser power, because we've accounted for the we've accounted for everything else but the laser power, which will sneak down and over here. We have laser power. We've got these two coming over that are going to be 2 and 10. They're going to have to be, I believe, one or the other, positive or negative. Cannot tell. I think they're going to be positive because there's a switch negative over there, but that just means that there's going to be a fan that most likely is it an always on then? That's the only thing I can think of. Look at the right set of wires. 1 and 2 on D. Thinking round, but if 3 is a fan negative, once again, why would you have two positives? Where's the other negative? Unless, yeah, I'm still so confused. I'm pretty sure that these are definitely fans. The question is are they fan positive or fan negative? It makes more sense that they're fan negative, but then that's on negative, which doesn't make sense. So that's where I'm getting confoozled. 6 and 7 are going to be laser positive over on this one, or laser positive negative. Which once again we're not using. I don't expect to use. We don't have a laser module. Hey Pete, how's it going? Um, so I'm trying to decipher some connections here. Um, you know what? Which connection is this? This is delta. So we're going to unplug the two fans. We're going to put delta. Of course, we're missing the interconnect cable, but I'm pretty sure that they're pinned straight through. So we've got that plugged in now. let's do some forensics. Get my whatchamacallit out, my multimeter. Few screws from the other night. Now, if we can go through and start verifying some pinouts, and we can verify that the pinout or the intermediate cable between the tool head and the box are in fact a pass-through straight through cable, which I don't see why it wouldn't be, then we would be good to say, okay, this is, we can then trace the couple of unknown pairs that we're looking for. So that there, we're going to put this on continuity. And what I'm going to start looking at is, do I have continuity on certain pairs? And I'm on D, not E. Find D to validate. So 3 would be a fan negative. Got thermistor, heater. Take a look. Heater. So heater would be E0. Continuity there. Getting, okay, so there's the break. Zero 03. Other way, that should do something. Okay, so confirm that one, that one. This is BL touch. There should be thermistor, heater, BL touch. I have a second thermistor. Don't know where that's going. And this should be the the fans. Grounds will be on either side. Not connected. Okay, so this is ground to the outer side. Which would be the part cooling fan, which means we should have a positive and a negative coming over here. So one of these is going to be a positive and one's going to be a negative. So that makes more sense. So one's going to be always on, which should be the tool head. We just need to figure out which one's positive and which one's negative. Okay, negative was on the outside, so D2 is ground, which would make D1 my positive wire, which would be the center pin. You So D2 is ground, D1 is positive, or 24 volt, and this is the hot end fan, because the hot end should be the always on, right? So that one be the always on. The switched fan, which would be D3, which is getting power across cable 1. So they're both getting powered at the same time. D2 is the hot end fan switched. So let me change that. This is fan power. HE0 fan switch. And then D3 is DC fan switch. Because you would use, if you have an always on fan, that's going to be the hot end fan, right? That makes more sense. What would we just say? 2 is HE fan switch. Or HE0 fan. We'll say ground. D2 hot end fan ground. That's how we do it. We validated that the connections that we know, right? We validated that those were the same by plugging the one at the tool head. So what happens is there's a cable that goes from this through the printer drag chains and goes up to a panel on the back side of the tool head that has a connection for D and E. And then D and E has connection from there, these short little pigtails that go up into the print head. So what we just did was validated that, yes, in fact, the that cable that goes between this box and the one behind the tool head is a through cable, as in pinned out the same way on both sides. Therefore, the two cables that were unknown, we were able to determine which pin each would be between positive and negative. Okay, so that one is there, which means this one is the 24 volt, the fan 24 volt. HE fan 24 volt. So like I said, I'm going to order another set of these 24 volt, or not 24 volt. I'm going to order another set of these bus bars because, well, the one I'm sitting here with is busted in half because it wasn't mounted appropriately. And we'll go ahead and what I'm thinking is I'll mount all three bus bars here. So we'll have 24 volt DC ground and then the AC side. And I'm making sure that all of these that are going to these terminal blocks are using fork connectors because it's either power, like active power, or return ground common. We want to make sure that they're properly connected. We've got those two now. The other two wires were coming off of E. We can basically do the same thing. We can connect in E and determine which one should be connected to power and which one should be connected to which one goes to power and which one goes to ground. All right. This okay. What I'm going to do is plug this 3-pin fan connector back in. And once again, E, we figured out what's the extruder, what's the other extruder. And honestly, I don't know which one would be power and which one would be ground. I don't think it truly matters unless I have a true pinout. Because what's going to happen is we've got the one I tagged here is the extruder. Go to straight bench view. So this is the one that was connected to the extruder. So I know that this is the hot end extruder. There's another 4 cable here, and this is the one that goes to the unpopulated driver extruder. So this is the would be for the laser head, which means these three, one should be power, one should be ground, and one should be the signal. So one of these is going to go to the signal pin that I have right over here. What I don't know is which one of these should be power and which one of these should be ground. as far as the pinout goes here. I would assume ground in the middle and power on the outside. I don't know. Um, one would assume that way, right? Power would go to the outside, ground to the inside. That's how all of the um, in stops and stuff are. Now all the servo pins would be, right? And this is in D4, so you think once again the middle would be power, outside would be ground. So let's take a look and see which one of these is our signal. So we'll unplug this. We will one end there. I'm going to assume my signal would most likely be one of the ends. Not that one. That one, the middle one, open. Okay, so this side is the signal pin. Once again, I'm going to assume the middle is most likely going to be the ground. What do I've got? I've got 6 and 7. So if we think the middle's ground, let's grab 6 on the ground pin and this wire. I can get my fingers to work with me. So we're thinking 6 is the ground. Thinking is the, nope. So 6 is the other outside edge, which would mean 7 would be the center pin. So 6, we think. Does anybody know what a typical laser pin is? Hey Daisy, how's it going? The 7 was the middle, which we think is ground. 6 is the outer pin, which we think it would be the power. You want to keep the power away from the signal is what I'm thinking. Was that right? 6 was the outside? Six is the 6 was the outside, 7 was the middle. Doing good. So we think 6 is laser power. I'm going to put, is there a question mark on here? All right, we'll do it that. We'll put question marks on it. So we got 24 volt and GND. So I've got two options. I can go ahead and connect these up to the power and ground and just have these marked as, you know, power and ground with question mark. Or I can label them, put ends on them, and just not connect them. There's nothing going to be connected at the other end, so there shouldn't be an issue. I think I will go ahead and plug them up though, because I just really don't want anything loose roaming around that could short something. Said 6 was on the outside, which we're assuming is the power. Is that correct? No. I'm confused. I don't know. We're going to assume, yes, that one's on the outside, that's going to be the power, and that the inside is going to be the ground, so that you've got a ground between the signal and the 24 volt power going in. I don't know. It should be the other way or not. I have 0 specs, hence why I put question marks on there. And by 0 specs, I mean I don't have a manual, so I have really no way of saying definitively on things like this. It's connected to the MCU, and I can trace it back from the MCU. I'm definitely good, but this is either a power positive or negative run up to the tool head without having what's supposed to be connected at the far side. I don't know. So we're making some educated guesses. And by educated guesses, I really mean, you know, let's emphasize the guess part here. Now, in talking with Waters, who is the gentleman over at EchoVate that was helping me dig through this the other day, they do not have a laser module for it, so that's kind of a positive. There can't be any issue because, well, they do not have the module, period. We want to bring these both through the this way or the other way. I think actually what we want to do is run whichever we put at the top. We'll run the one above, and the other one will go in the middle here, so it can come down into that middle bus bar. So we'll leave these loosies right here. I'm going to have to order the bus bars. I think I can get them in like next day. We'll see. Where was I at? Amazon. Can I get terminal block 12? Now I know I need 12. Oh wait. Hey, I already put it in my cart. 12th position screw terminal strip dual row with cover and 12th position pre-insulated jumper blocks, 2 pieces. So there we go. We've already got a red and a black jumper block. Comes with ring terminals. Nice. So we'll have the ability to bring in one positive, one negative from our power supply and use it as a bus bar. That's exactly what I need. Um, and I missed getting it tomorrow. We'll wind up getting it on Saturday. That's fine. The mains voltage one here is a hot mess in its own right, and the fact that once again we've got bare wires coming into it. We're mixing red and black wires along the way, which really just makes me cringe. A lot. And this is E, right? Yeah, we marked those. Okay. The other one we have here is these wires are coming up into A. Is that all? Can't be. Remind me to smack somebody upside it. Okay. So A is X motor and end stoppage. X and Y end stops. What am I doing here? Stabbing myself. Turn this off. Get this out of the way. These are going to just, I'll use these to do the 12 volt and stuff wiring once or not 12, the positive and negative wiring once I get there, because that'll be the bus bar. So this is the A stuff. We're getting there. We're getting everything mapped out, which will be good. I'll be able to put this all in a spreadsheet and we'll know point to point where everything goes to. And I love, like, on this particular one, they left the 3 extra wires sitting here and just, coiled them up. But most of them, they've cut all the extra wires. So, like, this one connector here just has 2 wires that come around to the, whatchamacallit. All the other dozen wires have just been snipped right at the aviation connector. So that's great. Oh, and none of these are. Those are bare wires to the screw down terminals. This is the SSR. This is power heavy gauge. This is power in, I think. This is going to the SSR. Then we have power back out to the heater. Yeah, this is great. All right, we're doing good. We're doing good. Let's figure out the pins here. We've got 1, 2, 3, and 4. 1. Here's our board. Okay. 1 is X, 2B. 2, is 2A. Third one is 4 is 1A. 3, 1. And then the rest of that loom comes in, and we've got end stops 5 and 6. So 5 is D3, 6 is ground, minus N. Then we've got unknown labeled wire. Great. D8 is ground. I'd almost assume that one would be D7, even though there's nothing on it. I'm going to make the assumption that it's D7 that's going into D2, which is X positive, which I believe is actually the Y end stop. Would make sense. The Y is empty. I don't think there's a min and max on X. Okay, and I believe that's all that's coming through based on what I'm seeing. Because this Y is what the? Oh, okay, yeah. The Y is on B. Double check what we had on cable A. We didn't have anything listed on cable A. Why did we not have anything listed on cable A? There's a lot on cable A. Cable B is Y-axis and the LED. So A was the X motor. And then stop. And Y motor cables. So the reason we're doing this, once again, we're making sure that our wires are cleaned up. We're making sure that everything that can be cleaned up, like we're putting ferrules on all the wires, we're tracing them and making sure that we've got a wire map done up. And that's what I'm working on right now, is just going through and figuring out what cable goes to where. So this is cable B coming into our top plate, and it's running the y-axis. So 2 is 2B, and 1 is 2A, 3 going to 1A. We put 4. Yep. Going to 1B. This is Y motor. And then we have a few cables that come around and go into the display. And I'm actually going to have to unmount the display to figure out what those are. There is also cable, aux 1 goes up to the display, which is fine. It's really, we got to figure out what these 3 or 4 cables are going up to the display include. We'd have to take the display off. I believe really wish I knew which of the, there's 2 thermistors on the hot end. I guess I could technically plug that other cable back in and try and figure out which is the hot end. One thermistor on the hot end. The chamber thermistor is a complete separate cable that comes out and gets connected. Or I'm sorry, that gets connected to the back panel here for the chamber heat and the chamber thermistor. Once I get this mapping stuff done here, then we'll be pretty close to did they have a, I bet you they have an E0 thermistor and an E1 thermistor set up. This is D. I think one of these would have to go to the bed though. Both of these definitely go up into the same cable bundle. What do I do with my multimeter? What we're going to do is we're just going to check and figure out which one of these cables is which. So we've got a cable that's labeled thermistor. So we're just going to grab one of those pins, grab one of these pins, see if we get continuity. And I'm not getting continuity there. Let me that again. Nope. So the top one not look to be connected to anything. See if the bottom one is connected to this thermistor. Getting nothing on either one. Should be getting some kind of continuity between one or the other of these thermistor cables. Could just be the way I'm trying to do it. How's it going, Maker Viking? Hope you're doing good. Well, and if there's no continuity, that may explain why they were having an issue. with a thermal runaway. There we go. We're getting something. So the top one, the top connector, which I'll have to look at the thing, is the one that's marked thermistor. So that's HE0 thermistor. I can almost guarantee you that the other connector would be going to the unmarked one on here, which would be the other thermistor. We'll double check that, I guess. We can double check that assumption. Who's there? Go there. Really? Like doing chopsticks. You're doing well, good. Huh. Not a thing. So where the hell are these wires? I don't know. From the top ones there. The bottom one, the only other thing I can think of is for the bed, because there would have to be something on the bed. I'm just not, yeah. It looks like that entire bundle goes to that connector. There's two unidentified or unmarked like things on here. Everything else is marked. I'm not seeing any cut wires. Do some quick math. 2, 4, 7, 10, 12, 14. Yep, all wires are accounted for. And that is a complete wire bundle. Nothing else is creeping in there. Yeah, I don't know. No sense being made. Okay. So I think we've got everything that we can figure out this way. I'm going to need the bus bar to make the connections over here on the bus bar. What we can do is look at securing that which we're going to have. What do you think? Positive at the top, negative at the bottom? Positive, negative? 24 volt, then ground. 4 volt, 24 volt. Because what I'm thinking is I want to run the 24 volt above here, ground down here. I'm going to bring this, put that one there. We'll put the other screw in. I'll make driver 1. I guess driver 1 secured back down in there. Now, one of the other things I want to make sure and do is that I get a ground lug on one of these. So I want to make darn sure that this whole case is grounded, because it's the way it was before. It was not grounded, which is bad. Once again, this side is the stepper communication with that's the step, direction, enable, blah blah blah. What's going on there? So that sat down there. I'll go ahead and clear this side. Whoop. Negatives are going to go between these. Positives at the top, negatives at the bottom. It also means that this negative is going to sneak in down here, potentially. No, we'll run that. We'll just keep that run up at the top. That's fine. Need another screw. Try and put that somewhat back together here in a minute. Did go ahead and order a set of M4 screws here so that we can make sure that everything was properly secured down, because, well, it wasn't. Again, metal things floating around with 24 volt and 110 power, kind of scary. So we're going to try and reduce the scary. God, how many pieces of tape? Going to try and reduce the scary, and there's enough oil in here. Probably oil that, another sewing machine with as much shipping oil as came in here. Loading WordPress plugins at the. That sounds like fun. The nice thing here is everything on the inside here is secured with M4 screws. So get our M4 screws in here and we can secure things down. Now the other thing that we haven't really messed around with just yet is this is all of the high power stuff, right? So we need to verify where some things are going, figure out why we've got a blue used for a ground. Kind of scary. Trace some of these wires back. So positive there, negative here. Really don't like these. Let me think through this. Got one set of power coming in. Positive, negative is tied to the positive, or line and neutral, coming to the front and going to the chamber heater. Okay. Then we've got signal wires coming down, firing off our SSR And then we've got power and ground coming from that. Ground comes out of the, or neutral comes out of there to the plug. The plug comes into neutral here. Okay. And what? All right. Let's just undo some zip ties and we'll make sure that we're tracing things right instead of like making it up as we go. Not that I was intentionally trying to make it up as I go. It was just, that's what happens. Okay. The big power and line and neutral coming down, going into heater, comes around to our mains, and it's directly connected to the inbound mains. Okay, so mains coming here. Signal pins coming out to our SSR. The neutral comes out to the plug. This is the power for the chamber heater. There's the neutral side. The power's there. I think these three went to the power supply. We had undone the other cable, so it came off of this side up here. So this side of neutral and this power was coming off the main or the other power supply. So one power supply is connecting the PSU into the chamber heater controller. The other one was driving the SSR and the bed SSR, because that's the other two cables that I haven't looked for. So here's one. Other one, positive, or excuse me, negative goes there. Positive. Okay, so one cable's powering the heated bed, the PSU, and the chamber heater controller. The other cable is running the actual chamber heater, and that's it. Okay, I think I figured this out. Still hurts my head, but I figured it out. Just trying to think how this should go. Technically, I can put one bus bar here and one bus bar here as well and run I don't know. Just seems really messy. Just seems really messy. And I just don't like having multiple bare wires and multiple wires coming into the same terminal. I like to kind of bus bar them out some. I wonder, should I just print should I print some Wago connect or Wago mounts and run some Wago mounts versus trying to do a bus bar like that? Somebody said I needed a Raspberry Pi, but I prefer cherry. There you go. There you go. Oh, for that matter, I could probably put a little bit of den rail in there and just use some standard mounts. I don't know. I'm just thinking through it. What do you guys think? We do bus bars? Should we do uh, Wagos? Should we do Wagos for the mains and leave the bus bar idea for the other one? Driver one. I mean, I think either way will work out just as well. Wonder if anybody has any personal preference there. In fact, my thought is, does this actually line up and will it mount on the M4 stuff? Oh, I could get two screws in that. I can run it either direction. Ooh, rhubarb. Yes, strawberry rhubarb pie is the shiznit. Mrs. Dragon used to make that all the time because we had a rhubarb plant at the old house. Do something like this. This, of course, a flathead would do just as good, but this works. This secures us down. We could do some Wago mounts on there for our mains voltage. get everything plugged up. That might work well. Not sure how many connections I would need, but I'd be able to run like 2 sets of 5 or a set of 5 and a set of 2 or whatever, because remember there's a couple of most of it's on one and the other one would be on a different circuit. I definitely need to get the things here mounted down appropriately. Don't know why that's not mounted down appropriately. Of course, the one side I did is the side that has the grounding lug on. Not long enough. Okay, what do we got? We've got 6, 8, 12. 12 would definitely work, but I think 8's going to be better. I don't want it sticking out necessarily at the bottom. There we go. Ah, now I know why they had bolts on there. They've stripped the threads. Barely hanging on. So now we will go with a longer one. Put a bolt on the bottom. Makes sense now. I have a regular bolt. I don't have a locking bolt, but or a locking nut, but I do have lock washers. So find a lock washer, a regular nut. We'll be able to screw that down. Bolt through the other side and do the same thing. There we are. Yeah, really not making a solid connection there. We'll lock washer and nut these. Want to make sure we got a good connection on your SSRs. The other ones that are on here, they don't have a lock nut on them, so or a locking washer, so we'll add one of those. Don't know how this machine is going to run and how much vibration it's going to have, so I definitely don't want these coming loose. Okay. I'm going to go through and put do that. They're semi decent. I definitely go through and redo the connections on the SSRs as well while I'm here. Make sure that those are all safe and sound. Apparently I need to dust in here a little bit more. Probably be a little bit easier to do if I was um had it sitting up on its sitting up like this. It'd be easier to work this particular screw. You guys can't see it done, but it will help. Maybe. Fat fingers, screws, SSRs, tight places. Them in there, yes. Right. Okay. That's secured. Need to secure our power supply at some point once we get that back in there. Um, That's over there. This is over here. That's there. We needed to take off our top cover here. Get a couple of things out of the way so I don't gouge my workbench any more than I already have. Probably not. Okay. That's kind of where we're at right now. We've cleaned up a bit of wiring. I still need to clean up a little bit more. I added this in here, which should allow me to add some Wago mounts. And I might be able to add some Wago mounts and get rid of at least one of the bus bars with all the high voltage stuff and get this cleaned up some because I really don't like the way that it's all mounting in there. I need to take a Swiffer in here and get some of the dust out. I need to do the connectors here, but what I wanted to do first before I forget was try and take the display off so that we can look at the wires on this and get them documented. Hey, thanks for the alert, Timor. We're going to undo the side screws that are holding part of it in. We'll take off 2 screws at the top. Apparently we didn't feel the need to do screws in all of the holes. Just realized that we're zoomed in and you guys can't see what I'm doing. So I'm just taking the screws off here and hoping, yep, are there, oh, okay, there we go. So this comes out and then there's 2 screws that hold it into the top of the case. So we've got the screen connections and then we've got 3 wires coming in, 5, 6, and 7. Signal, ground, and 5 volts. So this is for the runout sensor. This is the USB dongle to come out to the side with the USB stick. So we have the filament runout sensor comes up to this board. And those cables are coming from there. We're gone. Cables here, cables there. This strand of cable, which comes to connector Bravo. So Bravo I just realized. So caliber, right? All the words here are faced up. Cover faced up. The pages are, they put the cover on the wrong side of the pages. Oh well. Just an observation. Okay, pen. You go there for now. Pen. Bravo. 5 is 5 volt. 7 ground. 6 is signal. Run out sensor onto LCD. Why that connects to the LCD beats me. If anybody has a thought or an idea onto why that would connect there, I would love to hear it. Go ahead and try and put the USB connector back in. Hey, Hutch's Makerspace, how's it going? So we are dissecting a printer control box and just validating what cables are going where, when and how. Darn it. Unplug back in. So this particular set of cables and stuff is for a Optimus P1 Pro printer. And the build volume is 600 by 600 by 1100 millimeters. The printer was donated to Ecovate 3D, which is a local 3D printing shop here in Raleigh, North Carolina. And let me see, let me grab 2 more screws because Zed China here. And I've been given the pleasure of working on it. And right now I'm just trying to document all of the wiring. And part of that process is doing things like labeling the wires. So this is the emergency switch to 24 volt. Then we've got the 24 volt to panel switch, things like that. So I'm just going through and trying to get everything documented up so that when we do connect it, things should be working and we can validate some things if need be. The wiring, we'll just say, was in a sad state. Not a single connector had a ferrule or a forked connector on it. So basically what we were looking at, that one I can't even mess with. So this is a 12 gang terminal block that was busted, and it's just straight wire tied down, and I've had wires that I've just been able to hand pull out. So we're putting fork connectors on everything. I'm ordering a couple of new bus bars or terminal blocks because this one's busted. And what I'm going to do is I'm going to run one that's all positive, we'll run one at the top that's all positive, one at the bottom that's all negative, or vice versa. DC voltage coming back down to the power supply. And basically I'll do a bus bar across the entire lower part of it so that I can bring one power rail in and everything else comes off of it. Do the same thing on the DC side. I could probably do it with one if I just had, like, this setup here really actually isn't that bad You could do it with one where you bring your mains volt or your 24 volt in on one side, your ground in on the other, and tie everything in. Our mains power supply or our mains ingress here is on another bus bar, and it's a kludge. We've got dual wires coming to some things, single wires going to others. We've got two different power plugs, which is by design. One will run uh, the chamber heater, and the other one is running the 24 volt power supply and the bed heater, which is going through an SSR. The SSRs, once again, the wires weren't properly terminated, and I was just able to pull it off. So that's not good. I don't know. I don't think I can get my labels on this thick of a cable. Positive, neutral. Yeah, neutral, neutral. Next, positive to neutral. Same thing on the other one. Should be connecting positive to neutral, which is what's throwing me because positive's direct. Did they even connect that right? I'm not sure if these SSRs were even connected up right. But anyhow, I'm going to have to order a couple more parts to finish this side of the wiring. This side is all goodish. I'm still debating trying to redo some of this wiring because once again, it's bare wire clamped down on screws, but the screws are also, I would have to go to a smaller, I don't even know if I can get a number 6 fork connector on those. That might just have to stay the way it is. We've got two wires that come off and come up here to a connector H, which is the chamber thermistor. We've got 20 or mains coming in, and then signal coming out to drive an SSR with the mains going out to the chamber heater. So I think kind of where we're at is, we're getting closer is kind of where we're at. I need to get in here and do at least the high voltage side of the SSRs and get those connected. Um, so for the bed, it appears that they are just switching. Yeah, so there's the neutral comes in, neutral, whoops, neutral's on one side, neutral goes out to the bed, and I have to look at that again. So this neutral, black wire, goes to one. The other side, black wire. goes out to the bed. Positive goes directly to the bed from mains. So for the bed, they're switching neutral or with the relay. The other one, they're connecting live in neutral. Does that make sense? I don't know. My brain hurts. My brain hurts. Yeah, I'm gonna throw connectors on these SSR wires one at a time. Get them reconnected up. We're using 18 to 22 gauge port connectors for number 8s. So they should be fine to fit on these wires. I'm going to double, triple check. These might be 16. Connection. And hey, I just tightened these down, and now I'm going to have to get in here and unscrew and screw in these nuts. It's going to be great. I wish I had a stubby screwdriver. Be able to move that. And now, like I said, I think I'm going to start running into problems with catching the SSRs. So I probably want to disconnect these darn things so I can pull them out and work on them, then put them back in there. Means undoing these bolts. For nuts, bolts and nuts. The threads in the thing itself are stripped. Yay. So that's why I'm using nuts on the back side, and the nuts that I'm using are actually standard nuts. So I've luckily the kit that I bought came with some lock washers. So we are able to use some lock washers, and we're going to be able to secure these down good so that they don't come undone. That won't go. Where'd you go? I miss you so. Feels like forever. Hmm. Do not know where it went. Like I said, we're going to go ahead and take these off. We'll get some uh, connectors on it. And the more I look at this, it kind of looks like it might be 16 gauge. So we'll grab some different connectors. Forks. One more. One more large fork. Down some. How's it going, Eagle? 10. You need to get ready for bed. I had a statement, but I'm going to be like, okay, yes, I understand. Okay, because these are blue connectors, we'll use the middle one, which is our blue connector. There we go. Go ahead and take the other one off and redo it. Engage. So I'll do this one, get it back connected, and then we'll take the other one off and do the same thing. A lot better. Okay. We'll leave it a little bit loose, and I'm gonna, here's my other screw. I'm just going to tighten these by hand. Once again, they are lock washers, so I'm pretty confident they're not going to come off. Oh, Eagle, did you get the email that I sent with the hotel reservations? Try not to get in trouble, so I'm asking them questions. The one that doesn't have stripped out threads yet. Stripped out threads and definitely hard to find. There we go. Yes? Okay, good. And of course, these wires are tied down but good. Get these off one at a time. We'll get it crimped. Be able to see me doing this. This wire is definitely not that long. Well, it's long, but it's oh, whatchamacallit. It's zip tied in there, but good. And I'm trying not to undo some of the 50 bajillion zip ties. This on there, we'll get the other one off and get a nice terminal on it. And then we'll be ready to call it a night. So for those of you that weren't here at the very beginning of the stream, I am not streaming Saturday morning. Okay? I am not streaming Saturday morning. Instead, I am going to be attending Echovate 3D's grand opening. I will try and get some pictures of this actual printer. I posted a few, but I'll try and get a couple of newer, nicer pics. Maybe with me sitting next to it for size. I don't think, I don't think I'll be able to have this ready to go back in and start testing. And really, like I said, it's the open house, so I don't really want to have that thing going on during the event. But I expect to have this up and running and ready to start pushing plastic fairly soon. I've got all the stuff for the hot end. I need to rebuild the hot end, the whole tool head extruder assembly. I've got everything to get that going. Well, I can reuse the extruder that I have or snag one from the Kitty Tech because I'm waiting for parts for both of them. And they use the same exact extruder assembly, which is kind of weird. Was not expecting that. So I can snag one of the extruder assemblies from that for now to get it up in testing. Now I do have a what am I looking for? Not that. I do have a all metal extruder assembly coming for it because the intent is going to be to run, shall we say, some more abrasive type filaments through it. Or at least that's my intent because I want to use it to print some like recycled PET GCF from Polymaker, probably a few other things because it's going to be fully upgraded with a nickel plated copper heat block, a titanium heat throat, a Fadus hardened 06 volcano nozzle. Good gracious. There we go. Hey, Daddy Wazzy, how's it going? Welcome, welcome, welcome. We have been working on getting the electronics here cleaned up all night long. This is the electronics for the Optimus P1 Pro. And we've had to, we've done some wire tracing. We've done some, we've been working on putting ferrules on anything that goes into a screw terminal for the most part. We didn't do ferrules on the screw terminals that are going in the blocks here for power, but we also put fork connectors on them for our bus bars. I put this in here because I may wind up doing a set of Wagos and getting rid of one of the bus bars for all of this mains power. We've been trying to clean up the wiring. Like this blue wire is actually ground. And this was the ground that they had going to the power supply, which was a bit disturbing because it was also sitting right next to the neutral wire, which was also blue, going into the power supply. So one wrong oops, and you've now you've got ground and neutral connected, which might not be bad, but it's also not going to make the printer go burr when you want it to go burr. So I think we got everything up here. We got ferrules on all of our connections going to the board. JSTs are looking good. Wires are routed a tad bit cleaner. We have been going through and documenting aviation connector E pin X goes here type of thing. So I can build out that wire map. Like this one right here, we've got 1 and 2 on aviation connector H, which we know is the thermistor. So there's really no positive or negative on it. It's just, okay, it's the thermistor. These two are jumped together. This is the signal going out to the SSR to turn on the chamber heater based on our thermistor. This is the mains voltage coming in to our chamber heater controller, which is great. Um, yeah, so that's kind of where we're at. I'm ordering some new terminal blocks, so we'll be able to do a terminal block like this that's power or 24 volt, and one that's ground or common for the DC side. And then, like I said, I think I'm going to wind up doing something different for the mains to get everything connected in a more appropriate manner. Now on the mains, we've got one power cord that's running the PSU and what is PSU and the heated bed. And then the other power cord, hold on, let me look at that. So yeah. One power cord is heated bed, chamber temperature controller unit, and 24 volt, 800 watt PSU. The other power supply comes in and is basically providing power to the actual chamber heater itself. There's a separate power cord that provides power to the chamber heater itself. So yeah, that's kind of how all of that's going. Now I could try and cut some DIN rail and move all of this over to Wago connectors and get rid of the bus bars altogether. That's still a potential option. But I think I'm going to leave it. I think bus bars or terminal blocks for DC voltage, Wagos for high voltage, and we'll be good there. I think that's the way we're going to go. So I can work on printing a mount if I don't have one already available here, or one that I can snag off of the whatchamacallit, the rig stuff. But right now we're pretty far along on at least making this safe, so we're not going to shock and potentially kill anybody touching the machine. One thing I definitely want to do is ground this entire electronics box. I've got an extra standoff over here. I'm going to be able to, I'll put a ring terminal and screw it directly to one of the built-in standoffs here. So it'll be grounded to the chassis here. There's 4 bolts that hold this case to the side of the printer. And for those of you that haven't seen it, when I'm talking about the printer, I'm talking about, where's my mouse? Where's my mouse? Need my mouse. Mouse dead? Mouse? Where's my mouse? Plugging mouse into power. Apparently it was needing love. Maybe. There we go. So this is the printer I'm referring to. I've posted some pictures on Discord and on X about it. This is 600 by 600 by 1100 millimeters print volume. It has a mains heated bed, a heated chamber, 16 millimeter high wind rails, MGN 16 high wind rails on X, Y, and Z. The Z axis is run by NEMA 23 stepper motors, which are why we have these large chunky external drivers. They're running 24 volts, but 4.8 amps maximum to drive those NEMA 23 motors, which are driving 16 millimeter ball screws to lift the bed up on them. To get an idea of the size, this is the open air version, the standard P1. And I don't know how, normal guy. This Saturday, I'm planning on having some pictures taken with the printer so that those of you that know me, like I can say I am 5'8.5", and you can go, okay, this is about how big that printer is, right? So that'll give everybody an idea of what the size of the printer is. For now, I'm gonna keep chatting while I start to clean up some things here. But that's the printer that we're working to get up and running over at Ecovate 3D. It's actually pretty cool that they've reached out to me to see if I'd be willing to help to get this up and running for them. That thing. We still need to assemble the spool head back together. Here was the DC side that's broken in half because it wasn't secured down, so it was just bouncing around in the case as they moved it around. I'm not saying good or bad. I'm just saying that's what happened. That's the way it came to us. I'm trying to find. There it is. The zip twist tie to hold this. So Daddy Wazzy, what are you up to these days? Working on anything cool? So I've been working on this. We've been working on the Trident 350 that's sitting down here, working to get that updated and upgraded. There's a couple of the connectors here that were not sure if they were positive, negative, or what, so we had to pin some cables out. Working on a data center move. Oof. I don't miss those. We're getting ready to have one of those done. They're moving part of our data center from one of the buildings in San Jose into a colo in Santa Clara. And I'm just dreading when that happens, just because the impact it's going to have across our applications, because it never goes off without a hitch. Which means I'm expecting some type of downtime and issues to crop up from that. As often occurs. We were using our P-Touch label maker and trying to label as many of the connections as we could, as far as like the power runs. So we've got connections as from, 24 volt to panel switch, emergency switch to 24 volt rail and stuff like that. We're trying to get that done. Like I said, I do have all the parts to rebuild the tool head, which was a disaster. Looked like they had caught it on fire at some point. We'll do that on another stream. Probably work on this Saturday night. If we reinstall this part cooling fan, my thought is we'll have Ecovate laser cut a panel here, and we'll have like a mounting point for the fan here and possibly one back here as well. And we'll just run those directly to 12 volt power. Um, you work at a credit union, so the money can't be offline. Exactly. I mean, I work for Cisco, and it's going to be kind of the same thing. The stuff that my team works on is basically the entire CI/CD tool chain for all of our developers. So when our stuff's down, everybody claims, we can't push product, we can't push updates, we can't get um, bug fixes to clients and stuff like that. So it always drives an escalation, which is always fun to deal with. Um, I think I'm close here. We're gonna go ahead and put this away. Because I've got all the screw down, like tiny screw down terminal stuff done. Next up will be um, the rest of the stuff will be, like a number 2 screwdriver to screw things down. Um, and then, yeah, I think we're getting real close to this being able to go back in, get attached to the printer, and start testing some things out on the printer. Um, I'm going to reach out to the company. I've ordered some parts from the company um, because, like, our extruder gear here is kind of mangled a bit. It looks like somebody took a pair of pliers to it. So I've got a couple of these coming in, and I ordered them from the company, which is in Sweden, because this has set screws on it. Um, Hopefully I can get that set screw out. The extruder component itself is plastic, and it's about worn all the way through. The fan here, I'm going to figure out a new mounting solution, because the way they had this fan mounted, let me see, get that balance. Um, so the extruder comes through the back plate, and the hot end's right here. This fan was mounted like this, and the cooling fan for the part pulling fan was mounted like that. And so if you look at that mounting, I can get my big fingers out of the way. I don't know about you, but I don't know how this axial fan in the back is getting any air to move, which is probably why it's seized up. It's also Bluetooth. It's wireless now because the wires were off of it when we looked at it. But it's crunchy. And it's probably because it's been basically acting as a vacuum to pull a vacuum, and it's not cooling the hot end down, which was probably why before I cleaned this up earlier today, you can still see a little bit of the residue left. There were scorch marks here. Like something caught on fire on this tool head. And it has a brand new thermistor and heater in it. I got the heater out. The thermistor is not coming out unless I use percussive persuasion. So I just bought some new thermistors, and it had a PTFE lined hot end. So on a 600 by 600 by 1100 size machine with a heated enclosed chamber, and they have a PTFE lined volcano. So I've got a titanium heat break from Polish 3D. right? So we got a titanium heat brake or heat throat, whatever you want to call it. I can get it out here. There we go. So bimetal titanium, that's going to go into a new high temp heat block. We'll have I'm trying to decide if I'm going to leave the same 60. When I say high temp heat block, so this is nickel plated copper. So this goes up to 450 or 500 degrees is what this can physically take, right? So this with an all metal titanium heat throat or heat brake. This is a PT1000 thermistor. We won't put that in directly. We'll put in a regular HTC thermistor because once again, this runs Marlin and we need to stay compatible, right? So we'll start off with that thermistor. And the reason I say we'll start off is because we're pretty certain in the very short to near term that we're going to take off this NKS Gen board and possibly put something else in its place. Or maybe we just leave it, we throw a Raspberry Pi in here somewhere and we clipperize this thing. But I want the ability to go all metal. The volcano nozzle, where'd that one go? Got new blower fans. I've got axial fans for it. And where's it at? Anywhere. Oh, I think it's in the box. I've got a 0.6 hardened steel nozzle from Fadis, volcano style. That'll go in this. So we'll have a 65 watt heater, the potential drop in a PT1000 thermistor, and a block that can go up above 350 degrees. We're going to need to get a hold of the Marlin config in such a way that we can get all the data out of it so that we can consider clipperizing this and then be able to run some cool filaments like, I don't know, maybe PPSCF. I know that Ecovate right now has several of the 3 kilogram PETG recycled PC or CFO8, which the size of this printer, it'll want to chew on things. So let's give it some big filament spools and some big projects to throw at it. The extruder on it was plastic and it's about to break through just from the friction and wear of the filament. And so I have a metal one coming in from AliExpress. And I also have a couple of the plastic ones coming in. So whichever one gets here first will go on it so that we can start printing with this. But yeah, kind of where we're at, kind of what I have envisioned for this. As long as they let me tinker and play and, I'm going to tinker and play. What else? We've got the Trident 350 back here we've been working on that we're going to continue to make progress on once parts come in. I did order a Manta M8P for it and a beacon probe from West 3D. I did get shipment notification on that, so next week that stuff will come in and we'll work on that. I'm also waiting on parts to repair the Keytech X Plus. I need thermocouples for it. So I have a few varieties coming in to try and get that back up and running for my one of my friends on our Friday night D&D crew. So, yep, those are projects. And of course, we're building a Death Racer for Mrs. Dragon. drag racer for KB3D. I think I've got all the parts in for that now. No, I've got everything but the speed controller. So we should be able to go in and start getting everything set up for that. I've already got the chassis body built because I had a spare body sitting there. It's carbon fiber PLA. We need to print wheels and a couple of other things for it in the body, and we'll be able to get that going. But yeah, a couple of good projects going on, a couple of things that have to get done before we go to Rocky Mountain. Hotel has already been reserved for Rocky Mountain. We will be driving, so that's going to be fun. That's going to be I think Mrs. Dragon may take off a day before me and Evil Diesel do. That way I just don't have to take as much time off at work. Yep, that's kind of where we're at. Let's see who we can raid over to. Not sure if Jano's still running, or if he's called it a night. And if he's called it a night, then Zombie maybe. So let's see. Astro Canuck, Panuta, Juana, Kobe Lax, C. I. There's Jano. Looks like he's doing marble races. Don't know how far. Whoop. Looks like he's done with marble races. They're announcing the winners. What do you think? Should we jump over to Jano and then follow him out wherever he goes? Because that is normally a sign that he's almost done. Let's go ahead and do that. I have a feeling a lot of you are over. We'll go ahead and get that raid started. Thanks a lot for hanging out and chilling with me as I work through this cool little project here. More to come. I will see you guys Saturday later in the day because I'm going to attend the Echovate 3D open, or not open house, but grand opening here in Raleigh, North Carolina. So thanks a lot, everybody. Have a great day, and I will see you next time. Bye now. And if you're watching this later on YouTube, thank you for being here. If you like what you see, please hit the like button below. Be sure to subscribe. Click the bell to make sure you get notified of new videos when they're available. And YouTube's going to be suggesting a new video for you over here. You guys have a great day.